Let me tell you something, guys. This problem, it's not cool. It's not fun. It's not interesting. It's frustrating. But that's all right. Sometimes you have to do frustrating problems. You don't always get to involve yourself and engage in things that you think are easy. This problem is so difficult that it makes it difficult to communicate with you guys on the other side of this screen. But let's go ahead and try to get right into it. So for full disclosure, I have more. Did you hear that? That was my Alexa. My Alexa likes to try to notify me of things every 5 seconds because they fired half their dev team. Alexa, shut up. That's how you get respect in my house. See how distracting Alexa is, dude? It's so annoying. Okay, whatever. Yeah, so full disclosure, I've already kind of read over this problem a little bit. I literally sat here for like 10 minutes and just thought through how to solve this. So I don't know if I'd be able to honestly approach this in an interview just with high pressure. All right, because even in a low pressure environment, I was just sitting here like for about 10 minutes. So, but I think I have a general idea about what you're supposed to do. Okay, so given a set of distinct positive integers nums, return the largest subset answer such that every pair answer I, answer j of elements of the subset satisfies answer I mod answer j equals 0 or answer j mod answer I equals 0. Okay, if there are multiple solutions, return any of them. All right. So this problem, when it says subset, you can think of that as just being like a subsequence, right? Because with the subset, you can choose any elements in the subset. You don't need to necessarily choose, elements in order, right? Like you don't have to choose elements in order. You can choose like the first element, then the fifth element, then the 10th element, then the 12th element, right? You don't, you're not forced to choose it the other way, if that makes sense. Okay, so for this example, 1, 2, 3, right? You can choose 1, 2 or 2, 1, 3 because 2 mod 1 is 0, 3 mod 1 is 0, right? But 3 mod 2 is not 0, so you can't use that. 1, 2, 4, 8. All of these are pairwise, meet this constraint, right? Because 2 mod 1 is 0, 4 mod 2 is 0, 4 mod 1 is 0, 8 mod 4 is 0, 8 mod 2 is 0, 8 mod 1 is 0. So every pair, right, meets this condition. So one thing this problem kind of indicates to you is that there's an n squared solution is the constraint that num's length is less than 1,000, right? So that's 10 to the 3, so that's squared is 10 to the 6. So 10 to the 6 operations are definitely feasible, right? That's a manageable number of operations, right? If this was 10 to the 5, maybe I would be concerned about the existence of a optimal, I guess, n squared solution. But since this is such a small value, right, that indicates that there's probably an n squared solution. So that's a nice thing about these kind of problems, right? If you're doing an OA or whatever, in an actual interview, they may not actually provide that information. I would ask for it, right? Because this information can, depending on the way the problem's structured, indicate the runtime complexity. Now, don't put it past an interviewer to lie to you or to not to lie, but to mislead you and be like, oh, it can be anything, right? Because the interviewer might not be thinking about what's actually feasibly possible, right? If the best solution is like 2 to the n, right? If the optimal solution to some problem, it's like a traveling salesman problem where there's like an exponential factor. I'm going off on a tangent here, right? But there's an exponential factor, yet the interviewer is like, it could be any length. Well, in reality, it can't be any length, right? Because if there's an exponential factor and you're saying it's any length, for some length input you give me, this problem will never finish, right? For all of our lifetimes and probably the existence of the universe. So this information should indicate runtime complexity, but it doesn't necessarily have to. I'm rambling way too much. I'm sorry. Let's go right into the problem. Okay, so how do you do this? Well, who knows? If you're given, let's do a different example. So let's do an example that I thought of, which might be a little more interesting. First, let's assume things aren't ordered. So let's say like We have 10, 5, 1, 2, and 20. Now what I'm going to do is just force that test case because I think it could be helpful. So 10, 5, 1, 2, and 20 gives us the answer what? So this is always a good idea, right? Run a test case, see if you can get some information. I forgot, Python gets mad if there's no body of functions. Okay. All right, so 1, 2, 10, and 20 is the answer. Also, notice how it's strange that it reordered the subset. So this actually could be helpful in trying to get you to understand something about this problem to kind of give you a better solution. Okay, so the answer is 1, 2, 10, and 20. Okay. Now, why is that the answer? Well, we know that means, right, that all these things are mutually pairwise modular, right? Like 2 mod 1 is something, 10 mod 2 is something, 2 mod 1 is 0, 10 mod 2 is 0, 10 mod 1 is 0, 20 mod 10 is 0, 20 mod 2 is 0, 20 mod 1 is 0, right? But if something mod something is 0, that means that they're divisible, right? So there's some value, right? 1, and then if 2 mod 1 is 0, that means that 2 equals 1 times k, right? Where k is some value, of course that value is 2 in this example. If 10 mod 2 is 0, right? When I ask, okay, then is... Right, so when I do this calculation, I can say, okay, since this mod this is 0, that means that there's something times 1, which equals 2. So I'll just say 1 times k equals 2. Remembering still that this is 2 here. So then if 10 mod 2 is 0, right, that means that 10 mod whatever this is 0. So that means that 10 mod 1 is also 0. Right, so if that's the case, that means that if 10 mod 2 equals 0, right, I'm trying to do some modular arithmetic here. I'm sorry, I'm all over the place. If 10 mod 2 equals 0, that means that 10 equals 2 times something. We'll call that L. Right? Okay, but we also said that 2 equals 1 times k. So that also means that 10 equals 1 times k times L. So, and with the factors of modular arithmetic, if 10 divides 2, it has to divide these factors as well, right? So it also, right, if 10 mod 2 equals 0, that means that 10 mod 1 times k equals 0. In order for that to be true, that would mean that 10 mod 1 and 10 mod... Did I do this the wrong way? I'm doing my freaking mods backwards. 10 mod k equals 0. Right, so this is just a factor of modular arithmetic, right? So if 2 divides something and 10 divides 2, then 10 also divides something. Right, so it kind of has a transitive property there. And you can kind of think it through, right? Like 10 equals 2 times 5. Now think of all the factors of 10, right? So 10, 20, 30, 40, 50. Notice that these all mod 2 and 5, right? Because like if it mods 0 the number, it has to also mod the primes of the number, or the components that create that number. Right, so 4 times 3 equals 12. I'm just trying to think some other examples, right? I'm not going to give you like an inductive proof or something about why this is true, but I'm just trying to show you some examples so that you can kind of at least convince yourself that it's true. Right, so, all right, so then what are things that divide 12? Well, 12, 24, 36, 48, right? And notice that 4 divides all of these things, and 3 divides all of these things. as well as, well, what's 4? 4 is 2 times 2 times 3, and 2 divides all of these things, right? So that's just, I'm not going to go through it anymore, but basically what I'm saying is, if x divides y and y divides z, then x divides z. So what that's basically saying is, if I have this array, right? Well, the first thing I want to do is put it into order, which is why the answer returned in order, right? If I have 10, 5, 1, 2, 20, probably the first thing I want to do is sort it, because it doesn't matter the order of the elements because I'm choosing a subset, right? So the first thing I'd want to do is sort it and then pretty much play this game. So if I have 1, 5, what's the 1, 2, 5, 10, 20, okay. So if I have it sorted 1, 2, 5, 10, 20, right? Then I can just look to the elements to my left, because I'm never going to divide something that's greater than me, right? 2 is never going to divide 5. There's no 5s. There's no 5 times x that equals 2. There's no 10 times x that equals 2 if x has to be an integer, right? So you only have to look at elements to your left. So when I look at 2, I say, who to my left divides into me? And I say, okay, that's 1. So maybe we should rewrite these as... okay, like this, as nodes. So when I ask 1, is there anybody that goes into you to your left? No, I'm the first element. I ask 2, is there anyone from your left that goes into you? And I say, yeah, 1 and 2. And then I ask 5, is there anybody to your left that goes into you? That mod you. 5 mod 2 is not 0, right? 5 mod 1 is 0. So there's this link here. Then I ask 10, is there anybody to your left that goes into you? Yep, 5. Then I ask, okay, 10, does 2 go into you? Yes. Does 1 go into you? Yes. Then I ask 20. 20, who goes into you? Well, 20 could say, okay, 10 goes into me. 5 goes into me. 2 goes into me. And 1 goes into me. Is that my example problem, or did I just write the... Okay, so then I would just argue then that the answer is just the longest path through this system, right? And the longest path is here, from 1 to 2, 2 to 10, and 10 to 20. You could also do 1, there's another longest path, right? You could go 1, 5, 10, 20. So why can't I do that? Why can that be the answer? Well, if you look at something like 20, right? If 20 divides 10, using this kind of brute force, primitive primate math that I probably could do in a cave, right? That I look like I'd probably do in a cave, like 4 times 3 equals 12, right? But what we were trying to show here, which is applicable here, is that, well, in this path, if 20 divides 10, right, that means that if 20 mod 10 is 0, that means 20 mod whatever 10 mod 0 is also 0. So that means that all of these links also apply, right? If 20 mod this is 0, then 20 mod this is 0, and 20 mod this is 0, and 20 mod this is 0. Just from that transitive property, right? So if there's a link to another node, and these things are sorted, if there's a link from here to here, then this mod this is 0. And if there's a link from here to here, then 10 mod this is 0. And anything that leads into this, and anything that leads into that, and so on and so forth. So 10 mod this is 0, and whatever leads into that, also 0. Now when we go to 20, if 20 mod 10 is 0, then 20 mod anything that leads into 10, 2 is 0. if 20 mod 10 is 0, that means 20 mod 2 is 0. If 20 mod 2 is 0, then that means that 20 mod 1 is 0, right? So that means that all the members together are pairwise meet this condition. Okay, so with that, let's try to get into the problem. Okay, so how are we going to do this in order to, because it's easy to return the length of this system, but we actually have to return the resulting array. So the first thing we should do with nums is just sort it. Because again, it doesn't really matter the order in which we return things, but it's going to be easier to process them this way because everything to your left is less than you. So those are the only things that could be considered as candidates. Now, I'm wondering if I should make like a graph or something. Like, what's the easiest way of doing this without... Also determining the longest length in the system, right? Because I need to keep track of... So we only need to determine the next length, like who the best is going into you, right? So for each of these, like for 5, I could say like, okay, who's going to provide me with the longest length path? And that's 1, 5. So I could say, okay, my prev is 1 and its length is 1. So that would make this, so if I did that system here, right? Because I could generate all these paths and then run some sort of algorithm like depth first search to try to find the shortest path, the longest path, and then return whatever that path is. But maybe a better way of doing this, which is a little more clean, would be to leave the system like this and then run through it like this. So initially all of these things would have path length 1. Okay. And then I'd ask 1, do you have any neighbors? So its prev would be its best prev. So the best person to come before it to make the longest sequence, we'll just call that prev. So, okay, your prev. So the prev of 1. Sorry, I'm trying to think about. Prev is nothing, right? Because there's nothing that can go before this node, right? This is also assuming that we'll know which system. Oh, we'll do them. Okay. And then we go to 2. So when we go to 2, we ask, okay, who's the best person to be your prev? Well, that would be 1, which would then, well, if the best person to go into me has length 1, well, then everyone that he has, I can also add. So that would mean I have length 3. And then I would say my prev equals 1. Right, so now my prev is 1. Now I go to 5. Length 3. Apparently I can't count. That's 1 plus 1, which is 2. Sorry, I've been using ChatGPT and I can't... So now when I go to 5, well, 5 can't mod 2, so it's going to discard it. It'll look at 1 and say, okay, well, I can mod 1. So I'll also have prev equals 1. And that will mean that my length is also 2. Okay, and then we go to 10. And when we look at 10, well, 10 could add 5 with length 2, or 2 with length 2, or 1 with length 1. 10's going to say, well, I can mod everything that comes before me equals 0, and it could choose either of these. But let's just choose 2. Let's just say arbitrarily that it decided that 2 was the neighbor, but it could choose 2 or 5, right? Because these both have length 2 paths. So 2 would provide me with 2 nodes. So my prev is 2. And then this will make this length 3, right? Because the one I can mod has length 2. And by the transitive property, I can mod all of their previous nodes. So that means I have length 3. right? So we're keeping this cached information so that you can determine who is the best person to attach yourself to, right? And then we'll look at 20. And 20 will say, okay, I can attach to 10 and it gives me 3. I can attach to 5, it gives me 2. I can attach to 2, it gives me 2. I can attach to 1, it gives me 1. Okay, well, 10 gives me 3, right? So that's obviously the best person to attach to. So that means that my prev equals 10. Yeah, okay. 10 can give me 3, so my prev is 10, the node with the value 10, right? And that can give me 3, so that means that I can get 4 if I use this path. And then I can just follow this prev path backwards, right? So I could find which node will give me the maximum length, right? Because that's what these things are telling you. So I start with that one, and I say, okay, my prev is 10. My prev is 2, okay. My prev is 1. And then my prev is null. So that means then my path is, and it will be in reverse, I guess. So 20, 10, 2, 1. And that's what I'll return. Okay. So that's how we'll process this. So we'll have to have a prev system. All the integer nums are unique, so then we can just say prev is a default dict. Or no. We'll just make prev a dict, and then we'll say the value of each node is also a dict. All right, so we'll look at I in range. We'll make this a default dict and then make the default value 0, I guess. So for I in range, we'll go from 1 to length of nums. And then you'd have to look at all the neighbors that come before you, right? All the neighbors that come before you, you have to look at all of them, and you'd say, okay, prev equals the max of v at prev, so the value of prev that can go into me, only if, so if nums at j mod nums at I equals 0, so now I'm asking, okay, can I attach to this node? Okay, well then it'll be my prev if its value is greater than my current value, right? So you do that for all of them, and at the end you find the actual prev that you use, so the v of your value, okay, so this would actually be value 1. So the v at this num then is going to be added, you're going to add equal v of prev. Prev of, Jesus Christ. Prev of nums j equals the value at whatever my prev is. So I take my prev and I take its value, or the value that I get from using this new node, j. Oh, shit. So this should be I mod j. Jesus. Thursdays, man. Thursdays. I'm foolish. So whatever I think my best prev is, yeah, but I want to select the, okay, sorry. So I'm either going to select nums of I. I'm either going to select prev of nums of I, or I'm going to select nums of j. And my key is for the num, I take the value of the num. That's how I determine who's better. And then my value adds equal whoever my prev is. Maybe this wasn't the best way of doing this because it's pretty messy. Okay. And then, yikes. Okay. So my maximum node so my traverse node, oh, this is really ugly, guys. I don't know what's going on with me today. I'm writing some really bad code. So the max of V key equals num value of num lambda. Okay. And then so this should be a default dict too. So while t node so our return, what we'll return is empty, and then we'll add the t node. So we'll say return append t node equals prev. This is such an ugly solution. I don't know why I'm writing it like this. There's something I'm not. Oh, then you gotta return it. Return ret. Alright, so we get almost all of it, but it's for whatever reason it's not. It should be capturing 1. Why is it not capturing 1? So if nums I mod nums j equals 0. Nums I is always larger than nums j. Right. So let's print out some stuff here. To get some information. That's why you don't want to write sloppy code, because then you get like some really bad stuff. Okay, so this is saying for 2 its prev is 0. Its prev should not be 0. So we should say the value of 0 equals 0. Right? Because it's going to try to pick somebody that it shouldn't pick. Basically, it makes no distinction between a length 1 node and a length 0 node. So if you choose nobody, which is saying that your prev is nothing, right? If your prev is nothing, that means you don't get any value. Versus if you leave it like this, you're saying if you choose nothing, you get a value of 1. Okay. So it's pretty ugly code, but whatever. You know, I'm pretty sure this is going to meet the nth squared time complexity, so... And then it doesn't, and you look like a fool! There you go. Just start at 0. Don't try to get funny with it. All right. Okay, so what's the runtime of this? Okay. Not proud of my solution today at all. So we have to source something, so that's n log n, right? So if we said that n equals the length of nums, right? So time, we have n log n here, right? But that's going to get shadowed by this here because we have to look at each num, and then we have to look at each num up to num, right? So you have to go to 4, then you have to do 0. You'd look at 0, then 0, then 1, then 0, 1, then 2, then 0, 1, 2, then 3, then 0, 1, 2, 3, then 4, then 0, 1, 2, 3, 4. So that's n squared, right? So this is n, and then an n here, additional n here. So that's n squared, and then you just have to traverse. So this is n, right? You just traverse through the system. So that's n squared. And then plus n log n, but again, that's going to be shadowed, plus another n, which is also going to be shadowed by n squared. And then for space, well, we have to keep information about the prev for each node, but there can only be one prev, so that's fine. And then we have to keep information about the value of each node, but since there's just each node, so that's just n for the prev, right? Because each node could have one prev, so it's n prevs. Each node can have one value, so that's n values. So that's just n space as well. N space, why did I do it like that? So big O of n. For some reason, I forgot to put big O here. I don't know what's going on with me. And, yep, there you go. So that's a nasty solution, but 69. All right, peace out, guys.